Alright, so the first question we're going to do today is almost identical to the candlestick question, so really I shouldn't have to do it. The only thing that's different about it is they don't tell you what's x and what's y. You have to determine that based on the scenario. So we're following the same thing as yesterday, that we can write linear equations to model real-world scenarios. And then we're also going to take a look at scatter plots today and how we can write linear models for them. On Monday, we'll look at using the graphing calculator to find models for us. So make sure you bring your graphing calculator. You actually get to use a calculator on your quiz next Friday. All right, so for each situation below, find a linear model and use it to make a prediction. So that's also something new. We didn't predict yesterday. It says a 2-mile cab ride costs $5.50. A 4-mile cab ride costs $12. How much does an 8.2-mile cab ride cost? Okay, so the first thing we're going to do is write a linear model. Then we'll plug into that linear model to get the cost of the 8.2-mile cab ride. Okay. So the first thing that we have to do is that we have to identify what's x and y. Okay, remember x is your independent variable, y is your dependent variable. So we have two quantities. We have mileage traveled and cost. Which one of those things depends on the other one? Which one is independent and which one is dependent? Ryan?
Cost depends on how you travel.
Good. The cost depends on how much you travel. So y would be our cost, and x would be the number of miles traveled. Y is usually cost, yes. X is usually number of items. It also can be time. It's time. All right, so up here we'll label x, 2 miles is x, 550 is our y, 4 miles is x, $12 is y. They won't always be in order like that, x, y, x, y. So just make sure you do actually do step 1. All right, the second thing we have to do to write a linear model is actually put those as ordered pairs and find the slope. Okay, so we have 2, 550, and we have 4, 12. Find the slope using y2 minus y1 over x2 minus x1. Go ahead. What do we get? Come on. 3.25, 3.25. Okay, we should get 6.50 over.
Brennan Wade, please come to the main office. Brennan Wade to the main office.
Which would be 3.25. Okay. So this is our m value. So now we have 2 points and a slope. So which form would I pick first to plug into, Augie? Point slope. So we will, I usually pick the first point, but you could pick the second one because it doesn't have decimals if you prefer it. No, because there's a y-intercept. We don't know the y-intercept is 0. You're assuming that it just charges you like per mile? Okay, this one, first of all, is not, you have to verify that it's charging you $0, but have any of you actually been in a cab? When you get in the cab, there's like a little box on the top, in the front. It usually has a price already before you get in. It's not 0. So they charge you just for like the pickup. And then they charge you per mile. Although some of them charge you for time instead of mileage, or a combination of the two, depending on traffic in like New York City and stuff. This one is not going to be accurate, and the Keystone never makes them accurate either for those of you taking it. Like one of them was stacking bowls. Does anyone remember the stacking bowl question? The y-intercept was -1. So like the height of 0 goals was -1.
What?
Like it didn't make sense. But like, so you just have to prove it using linear equations. If it were to come out to be, it charges you $0, you would have to prove that by finding y-intercept of 0. Okay? But that was actually a good question, Jax, because a lot of people will do that. All right, so we plug in a point slope. So y minus 550 equals 3.25 times x minus 2. And then we do usually change them into slope-intercept, so we'll distribute. And we will use inverse operations to add 550 to both sides. So this is another one that is not realistic, because we have -1. So the y-intercept is basically like you're getting in, and the CAP would say that they owe you $1 for getting in.
Yeah.
But nevertheless, now we can use this model to predict. Now 8.2, be careful. Sometimes they will give you one that you have to plug in for y, and then you'd have to add 1 and divide by 3.25. But 8.2 was defined as our x value. So we are going to plug in 8.2 for x. And just for the sake of time, I'll tell you what you get. Did you use a calculator, Jax? I didn't tell you you were allowed to use one yet. Okay, since you're allowed to use one on your next quiz. Always looking for the loopholes.
Well, I'm just saying, like, you got used to it.
Gotta get used to it. Where to press those buttons.
Yeah.
Alright, scatter plots. We should remember these, right?
Yeah.
Trend lines. Okay, so scatter plot is what it sounds like. It's a scattering of plots. But it is a relationship between two different sets of data. And they're useful because they can help you observe the relationship between those sets of data. Is it a positive correlation or a negative correlation? In Algebra 2, we will actually learn more than just linear stuff, I promise. So we will see scatter plots. That might make a parabola, which will be our quadratics, which we focus on a lot in Algebra 2. We'll also see ones that are cubic and quartic. So when you're classifying your correlation, you can have a weak or a strong positive. So the weak is when it's scattered about a little bit more. The strong is when it's clustered together. So those are both positive correlations, but the first one is weak and the second one is strong. And that's because this, if we were to draw a trend line in through it, it would be having a positive slope. The next two are weak negative and a strong negative. And the last one has no correlation, okay, because they don't have any type of line that could be formed. And then today we're going to work with the trend line, which is when you take and draw a line through the middle of the data. Now there is an element of error because you are looking and tilting your ruler to draw the line. I forgot to put rulers out. I'll do that right now. So we will be on Monday using the graphic calculator to give us the accurate model. Actually, you know what I'm going to do? I'm going to give everyone a popsicle stick because you don't need a ruler, you just need a straight edge. You can put this in your binder and you can use it anytime you're drafting a straight line. Now, these are not used, I promise. I didn't eat all these popsicles. Some of them are really perfect. And this way I don't have to pass out rulers. I used to write your names on these and then pull them at random to call on you. I haven't had time. If anyone's is like super crooked, let me know. I can figure
Josh, I'm sorry.
Anyone else want another one? That's like not.
Ow!
It's special. I don't know. You killed me.
You want another?
Stop.
Okay. Alright, so sketch a trend line for each of the scatter plots on the graph and then identify the type of correlation you see. So you are just going to take your popsicle stick and you're going to try to go through the middle of the data. We're not playing connect the dots. You also don't want the line to be like way above some of them or below. You kind of want to have the same number of points above the line as you do below the line, if that for people who like to count. But you're just going to do your very best because that is an estimate, an approximation. What type of correlation would we call this? Dark? I would call it a weak positive.
It's clearly positive.
Is there any like in between two and
I don't usually put them on the test because there's an element of interpretation to them. But we will when we get to the calculator problems and we're looking at the correlation coefficient, which is your R value, then you'll be able to tell me based on the number if it's strong or weak. Like for me personally, when I look at this one and I see them scattered and I look at the next one and I see them clustered closer, like I think this one would be strong because they're closer together than these ones. Like I compare the questions whenever I look at them. But so the next one, if we draw in our trend line, that one should be a strong negative in my opinion. The less points you have, the harder it is to tell. So the more points they put on the picture, and the last one? What did you say, Jax? Weak positive? I put strong positive.
was that
I
strong?
want to say it's kind of medium.
It's kind of medium. It's definitely stronger than the first one, though.
Yeah.
It is.
I think that's.
I think maybe his eyes are missing.
Like all of these points are closer to this line than these ones are. But again, it is open to a little touch of interpretation. All right, the next one, the first thing you have to do is plot all those points. So go ahead and do that.
Oh my gosh.
Oh my gosh. I'm gonna pause the video so that.
You're recording.
Oh well, whatever.
Oh, yes, sir.
No, I forgot to press record. Let's just go back.
Dan Hilty, please call extension 6505. Dan Hilty, 6505.
If you're watching this video, pause it and copy. Alright, so sketch in your trend line. And we need to identify which equation is the line of best fit. So again, I would check my y-intercepts first. It's definitely not 1.57. It's not over 10. It's not all the way down at 2, because if it were at 2, it would be like too steep or too shallow, so it has to be deep. Now, if you wanted to verify the slope, you could pick 2 points on the line and actually calculate, but since it's multiple choice, you don't have to. Okay. And the last one asks us to do a prediction. So see if you guys can answer that question while I pass out your homework. And before you put the homework away, I do want to call attention to one of the questions that some of you might struggle on. Just make one quick comment on it.
See power game maybe?
Probably not.
We used to have season tickets.
Not really want. Now we know.
Okay. What'd you pick? A, B, C, or D?
See.
Should be C. Okay, so I saw some of you doing like a bunch of work. Not required here. You really just need to extend the trend line to go past where it was, because they already drew it in for you. You don't have to write the equation of it and do all that work. They just want you to predict the arm span the height when the arm span is 200. So go to arm span, go to 200, go up to the line of best fit, which mine's a little bit off, and go over. Not a straight line, but you'll pick the answer that's closest to it, which would be 197. Okay. The way I drew it, it looked like it would be at 195, but still that would be the closest answer. All right, now really quickly on the homework, look at number 5. And I'll leave this on the video for those that aren't watching it. An empty 5-gallon water jug weighs 0.75 pounds. With 3 cups of water inside, the jug weighs 2.25 pounds. Predict the weight of the jug with 5 cups of water inside. Okay, so what would one of my ordered pairs be? Mason?
0, 0.75.
Perfect. 0.75. A lot of students won't know that. They'll put 5.75. If the container is empty, how many cups of water are in it? 0. Okay. So the 5 gallons is really extra information that are tricky. It's irrelevant. The other one would be 3.225. Okay, because the weight would depend on how much water is in the container. Okay. The other one should be fine. On the back you have some multiple choice ones. Should be a pretty short assignment for the weekend, aka homeroom.